download this and have it open in your editors because it's a bunch of material that I prepared just for this crash course. Oh, I should probably, no more waiting room. Nice. So, good evening. Some of you may know me as lowercase spelled in all capital letters, and I'll be your host for tonight's review session. In my own time, I've prepared some material for everyone that illustrates each of the object-oriented programming concepts in as clean of an environment as possible, and I highly encourage all attendees to download it and have it open for following along while I finish up this introduction. The link is in the Zoom chat. So, from my understanding, at the start of the semester, a lot of you were dumped very unceremoniously from a Python course into this one with very little time to acclimate to Java's unfamiliar syntax before you had the monster that was assignment when thrown in your faces. No need to take notes. I'm pretty sure that I have annotated all of the classes in the material over there. I'm not a TA, I'm a student actually, which is why yeah. But additionally, the fact that all of the early exercises from this course introduce way too many concepts at once must not have helped. And judging by the concerns I receive in DMs on Discord, some of you may have fallen behind. As such, I will be covering everything from the top. My ultimate goal for this session is to have everyone leave knowledgeable enough about object-oriented programming so that when you study the more involved concepts like binary search trees, you can focus on the problem-solving aspects instead of stumbling over the fundamentals. Of course, if you came here specifically to ask about those advanced techniques, I'll be taking review requests after the crash course so that everyone has a better chance of following along. So let's take a look at the breakdown. Acknowledging that the main difficulty comes from having each lab or assignment introduce way too many concepts at once, I'll be attempting to remedy that with Pokemon. So when designing this crash course, I found that I could cover all of the contents, almost all the object-oriented programming content by recreating elements from that game. Doing so lets me introduce each concept in isolation with the same file so you can see exactly how each concept improves our project and why. After learning the concept with our model of Pokemon, we can consolidate it by looking at where we've seen those concepts before in this course. So we also make sure that we stay on track and cover relevant material. So classes, static, constructors, these are going to be covered real fast because there's nothing too spicy in there. We'll be slowing down for inheritance through generics because that is the heart and soul of object-oriented programming. For exceptions and enumerations, these ones are a bit unique because they don't build upon the other concepts and they're pretty easy to learn on your own. So I'm only going to cover these if people ask. If there's time left over, I will be taking review requests. So if it's a practice exam, I'll narrow my thought process and dispense my personal debugging tips as we go through it. If it's something else, I'll do my best to explain it. So does everyone have my material downloaded? Okay, perfect. I can mute people. Power overwhelming, nice. Okay, let's start off with classes. Oh, not you. All right, so before we get into this, let's make sure that we all know what object-oriented programming is. So far in Python, all of your programs might have consisted of sequential lists of instructions. With OOP and Java, it's better to think of a program as a collection of objects. Just like real life, you can create objects that exist and you can combine them to form more complex structures. This allows for programs that are more reliable, easier to understand, and most importantly, more reusable. So for example, in a Pokemon game, the Pokemon themselves, the NPCs and Pokemon on the world map that you interact with and the items that they hold would all be objects. In OOP, you would create these objects and they would interact with each other just like in real life. So far, what you might be familiar with is using a class as a starting point from a program only, so public static void main. In Java, a class is rather used to define an object. So you can think of it like a master template. This is what you use to create actual objects. So going over this class real quickly, we see that we want every instance of a Pikachu in our game to have some amount of health and store its type. All of this is exclusive to a Pikachu. So we also give them a method that just says attack. And the way we call these methods is using the syntax object.member. So variables and methods that are not static in the class are all considered members. So here in this program, we are just setting its health to 20, its type to electric, and we print those out, just demonstrating how we access those things. And there's our output. It's also worth mentioning that in order to have these classes be aware of each other, they need to be located in the same folder. Is it still exclusive to Is it so exclusive to Pikachu if it's public? Yeah, so every single one of these instance variables, these are all exclusive to every single instance of Pikachu that you create. They all have their own. Public actually does something different. We'll be covering that in here in encapsulation. But for now, that is all we need to know, that we access members with object.member. Any questions, or should we move on to static? Okay. So for static, we have Pikachus and they can attack. But let's say that in-game, you wanted to track the number of times every single Pikachu ever created has attacked for the purposes of tracking game statistics. And to do this, one way we can go about it is using static. And a static member associates this variable with the class instead of the objects created from that class. So each instance of Pikachu that we create using the new keyword has their own health, their own type, and this attack method, because none of these are static, but attack count is associated with this class itself. And so we can modify this using the syntax class.attack count, which is over here. Whoa. Doing that real quick. So in this program, we instantiate the arbitrary amount of Pikachus, say 10 of them. We get 4 random ones to attack, and even though that there's 4 that are attacking, they all increment the same attack count over here because it's associated with the class. They don't store attack count on their own. That is exactly what static does. I'll be waiting 10 seconds in case anyone has any questions. If not, we'll be moving on to constructors. Open all the folders at once at the same time, i.e. I'm not sure. I'm using Atom, and I can just open the folder as a project, and that would let me, move over everything in TreeView. I'm not sure how it would work in other IDEs. So let's move on to constructors. So, and once we're done this, we can finally take a look at where we've seen all these 3 concepts before, that being in lab 2. So, a constructor is a method. You can think of a constructor as a method that runs automatically when an object is instantiated, so namely with a new keyword. And to create a constructor, the method must have the following. It must be of the same name as the class, and it also must have no return value. So this is more or less doing the exact same thing as what we had earlier. What's going on here is, when we say Pikachu is equal to a new Pikachu, we pass this as the health parameter. So that it calls this constructor here. Health goes in here, and what this keyword does is that it's referring to the health that's a part of the class specifically. So if you take a look at this scope, the scope of this constructor, there's 2 instances of health. There's the health that's being passed in as a parameter and the health inside the class. The way we differentiate that is using this keyword. Otherwise, it just defaults to the one as the parameter. So that is how health gets assigned. So we assign health, we assign the type, we print those out, and then we call attack, and everything behaves as expected. I guess we can go over lab 2 to take a look at where we have seen these concepts before. So let's just take a look at how security agent works. If the parameter was age instead of health, do we have to put those variables in the parameters of the constructor? If the parameter was age instead of health, we would need this. Actually, that's a good point. If they are named something different, you don't actually need this. This just makes it so that, because if we say we named the health new health and new type, there's no ambiguity here. The compiler knows that when you're saying this, it's referring to the parameter here, and health refers to the one here. Since it doesn't match any parameters, everything still works as expected. Do we have to put those variables in the parameters of the constructor? Not necessarily. You can get away with setting only one of these if you really wanted to, but it's good practice to make sure that to design your constructor so that each time you make an instance of a class, as much of the things get set as possible. So that way you avoid null reference acceptance down the line. Do those make sense? I'm just going to keep this because this is one of these two. Okay, perfect. Let us go back to taking a look at how this class works. What's notable here is we're doing an import. So even though there is no class named random inside this folder, we can still more or less understand how it works by taking a look at the documentation, because in here you can find information about the constructors, the methods, et cetera, et cetera. So in this case, we're just instantiating new random. Because they don't pass anything in, it's just going to take a random seed. And int first is random.nextInt. NextInt takes a look at the int that you pass in, and it generates a random number from 0 to that integer exclusive. So you have 0 to 4 plus 1, int first, second, and third. These all receive a number from 1 to 5, and those we pass into combination. So this is clearly calling a constructor because you see the new keyword here, but we don't actually know what it is. But we do know it takes 3 int parameters. So if we take a look at the combination class, those 3 randomly generated ints are passed in here and put inside the array of combinations so that we, the combination still has its own combination. Hello? Let's just mute you. And once we have that, we're instantiating a door lock. So what Combo isn't really describing the scope, so it's setting the security agent's instance variables. So door lock gets a combination in its constructor, initiates itself, activates itself, and we are all cool. So that is how constructors work. These are the absolute basics of object-oriented programming. At this point, we should know that in OOP, everything is an object. Objects are defined by classes, objects are made with constructors, and static properties are not associated with any objects. Are we cool on all of these concepts? Because once we move into inheritance, if you're not confident with these 3, it's going to be tough. So if you have any questions, ask them now. Also, let me know if I'm going too fast. What about primitives? Good question. So primitives and objects are a bit different in the sense that objects are all reference types and primitives are, how would I explain this? Objects can have primitives. The main difference between objects and primitives is that primitives will always be passed by value. But that gets into the differences between deep cloning and shadow cloning. But for the most part, objects can use primitives, but when you're designing things in object-oriented programming, you should still be thinking in terms of objects, not necessarily the primitives they contain. This is like when you're designing the overarching structure of a project. And once you start focusing on the object instead of the primitives themselves, I think that some of the concepts covered later on, especially the abstract data types, will become a lot easier to understand. So the primitives, you can think of them as what the objects hold, what the objects manipulate, but everything should still be designed around objects. Why is there a static and main methods? All we know about main is that when you type Java and then the class name, it searches the class that you pass in for this method signature specifically, public static void main. You can get like a pretty good inkling of why this is. Public makes it so that even that the compiler can access it. Static makes it so that it can call this method without needing to instantiate or run a class. And the arguments are any, if you were to call like, say ABCD, that would be passing in one argument, that argument being ABCD. So that's more or less how the main method works. So the reason static is here is because it instant is so that whatever's going on behind here, it's creating this. It doesn't need to create an instance of runner to run this method. That just makes it, it's just nice, I suppose. Saves some memory a little bit. We can't do private static, right? Private static, we will cover that in encapsulation because there was an instance of private static being in Dataset. We can cover that once we get there. But for now, I want to make sure that everyone understands what inheritance is. So a Pokemon game has to have more than one Pokemon. Like if you were to create a new class for every single Pokemon in existence, that involves a ton of copy pasting. And if you decide to change something for all Pokemon, like add a variable to store their speed, you'd have to change it in every single Pokemon class, which is completely unreasonable. And for that reason, we have inheritance, which lets one class inherit traits from another, which allows for like a hierarchical structure when you're designing your projects. So classes may have related characteristics may be a subset of another. So I moved everything that every Pokemon will have in common to the Pokemon class, to a superclass, namely being Pokemon. In this case, both Ivysaur and Pikachu are Pokemon, so they both inherit from this class. By doing so, we extend the members of the Pokemon class to include additional attributes. For example, Pikachu is just a Pokemon that's electric and it knows Thunderbolt. So let's take a look at this superclass. Everything here is as we left it. We have the int health, string type, an attack method. That is all pretty standard. But in the Pikachu class, the health and type are still accessible. Like we still can say, if you wanted to say system.println health inside the attack method, that would still be possible, even though it's not declared here. That is because it extends Pokemon, and that is where it can be found. One thing of note is overriding. So if you declare a method in a subclass that is defined the exact same way as the superclass, so in other words, the name of the method, the return type of the method, and the parameters in the method are the same in both classes, the new method overrides the superclass method. And the superclass method can still be accessed with the super keyword. So if you wanted this to call the one up here, you could do something along the lines of, for our purposes, we don't need to do that. Same applies for constructors, which is what we're doing here. So since basically every single Pikachu in existence will start off with the same amount of health and also be an electric type, we can pretty much generalize that and make sure that there's only one way to create a Pikachu class by, yes it is, one way to create a Pikachu class using this constructor here. So 20 gets passed to this constructor because we're calling super, electric gets passed here, so on and so forth. Oh God, that's a lot of questions. All right, let's go in order. What if, sorry about the private thing. I have the chat here so that in the recording people can see the questions that I'm answering. What if the instance variable of the superclass are private? Can we still access them from the subclass? Excellent question. We will be covering that in encapsulation. Do you have to add, but to answer this question specifically, no, they will no longer be accessible from subclasses. Do you have to add the override? What the override does is it tells the compiler, okay, I have full intentions of this method being overridden. If it's not overridden, I want you to tell me. So all it does is you see that if we compile this, the compiler has no problems with it, right? But if the signature doesn't match, so there's an extra E there, and there's an override tag here, it tells us the method does not override or implement a method. It just demonstrates and makes sure that these methods are overrides. It's just a safety feature, I guess. But I just added these so that everyone watching can understand what methods are being overridden. Sorry, this is a question about constructors. As in isn't set in the main method. Is there a use for this? When would it be better to do that than in the constructor? When you're creating an object, you should set as much as possible. But objects are things that change over the execution of a program. So even though for example, even though we're setting the initial health of Pikachu in here, they will start with 20 health. They may lose health later on or gain health from being healed. So that is when you would actually set, okay, Pikachu health minus equals something, something, something else. That is the case where you would set something without a constructor. Can we have a multi-parent class like a child of both Pikachu and Ivysaur? In Java, we can only extend one class at a maximum. There are cases where we can extend superclass-like structures, in other words, interfaces, but each class can only extend one class at a time, but they can implement as many interfaces as they like. We'll cover that once we get to interfaces. These are good questions. Okay. Are we all cool on inheritance? Oh, actually, we still have to go take a look at where this was used in lab 4. So in lab 4, we had these post classes, and these are, well, we know that every post to ever exist will have some amount of likes, a timestamp, and a username. These will be found in every single post. A post, text post, and photo post, they all have these properties. Each of them also has these methods as well. We want all of these posts to be comparable. We also want all of the posts to be able to evaluate whether they're popular or not for the algorithm, and they can all be liked. So this is all pretty standard stuff. Within photo post, well, a photo post is just a post that has a file name and caption, hence photo post extends post. So these are added in addition to the properties to the fields in post, members in post. And of course, the toString gets overridden to include data about the photo post. So super.toString, it's calling the toString over here, and then adding the information exclusive to photo post, the file name, and the caption. Text post, more or less the same thing. The only difference is isPopular is now being overridden because isPopular is probably like designed to be used by an algorithm to decide what to show people, but text posts in general are probably less popular than photo posts, which is why we do this override here. toString got the same treatment. It's just adding the additional information from the text post. All right, is everything clear? So multiple child classes can inherit one parent class, but one child class can't have multiple parents. Exactly, you got it. I'll wait a bit more just in case someone's typing. There's overriding and another one. Oh yeah, cool. Overriding, I know what you're talking about. You're talking about method overloading. Overloading is when you have two methods that have the same name, but different parameters. For example, let's just create one on the spot, shall we? Let's say we also have an attack, but this attack takes in target. And we know so now there's two methods that have the exact same name. This method, the method attack, is now considered an overloaded method. And what's smart is that the compiler always knows which one to call. So here we're saying Pikachu attack, and we're not passing in any parameters. So it's actually just, it's calling the right one. It's calling the one that doesn't have, that doesn't take in a parameter. But if we do provide it a parameter, so let's say itself, maybe Pikachu's confused, then it will call the other. Yep, oh hey, the other one got called as expected because that is what an overloaded method is. So overridden methods have to do with inheritance. When a subclass extends a superclass and implements a method with the exact same signature, that is an overridden method. If a class has two methods and one of them takes it and they have the same name, same return type, and have the same name and different parameters, that is an overloaded method. Extends and implements. Extends and implements are almost identical in that they will always inherit whatever properties that were inside the class that they extend and implement. But the main difference is extends is used for classes, implements is used for interfaces. We will cover interfaces once we get there. So does that thing about overloaded methods and overridden methods make sense? Does anyone else have any other questions? Cool. Could you do super.pokemon in the constructor? Super.pokemon. Super.pokemon, I'm not sure what that is attempting to do, but super basically calls anything that is in the parent class. So we're doing that here. Super 20 electric. So this is just invoking the superclass's constructor. So we take a look at what the superclass is. Pikachu extends Pokemon. That's invoking this constructor right here. So when we call this line, it's basically saying the same thing as, okay, this doesn't really make sense, but maybe it will make it work. This class is created as a new Pokemon with numbers 20 and right? Because that is just what's being called in the super here. Of course, this won't actually compile, but that's more or less what's going on when you call the superclasses constructor with this. And as usual, you can invoke whatever methods are in the superclass with super dot, if that makes sense. Maybe I misunderstood your question. If so, you can let me know. But for now, let's move on to encapsulation, where we can clarify a lot of the strange, and where is it? Here it is. So this is probably the most keyword-dense topic that I'll be covering, because encapsulation is fundamental to object-oriented design. So encapsulation is used to control access to class internals. And the reason we want to do that is that it prevents invalid data and misuse. So we have this attack count over here, right? Just for the purposes of tracking statistics. One of the problems is, imagine you and a friend are working on this project, and your friend doesn't really know like how things work. So they could possibly call the line attack count is equal to 999 somewhere, thus ruining all the statistics that you've been tracking all over your game. Or they might do something worse and set attack count Pokemon capital letter dot attack count is equal to -5 and input some invalid data. As programmers, because some of our projects can get really complex, it helps a lot to make sure that the chance of messing up is as absolutely low as possible. So it is true, if you are the most careful programmer in the world, you can make everything public and everything will still work. But that never happens, and so we have a huge array of access modifiers and other modifiers that prevent us from messing up. Let's take a look at the primary three, them being private, protected, and public. Linked lists, binary trees, and list revision. We can go over them, certainly, but I want to make sure that everyone is on track. But I want to cover that after the crash course so that people can follow along, as many people can follow along as possible. So private just means that it's only accessible within this class. So now that we've made health private, Ivysaur and Pikachu can no longer say super dot. This would cause an illegal access exception because it is now private. So that we can no longer use object.syntax to access health. And the similar line applies to protected. Protected means that it's only accessible to its inheritors. So now Ivysaur and Pikachu, these classes that extend Pokemon, they can access attack count, but the runner class cannot. Public means that everything is accessible to everything. As long as you are in the same folder as this class, you have access to it and can call it with the .member syntax. The reason we make health private is, we know that in Pokemon, each time a monster takes damage, you want to apply weaknesses and resistances. And there is never a case where a Pokemon will take damage that doesn't have a type associated with it. So rather than we going through our code looking for every instance that we would apply damage to a Pokemon and adding the if check over there, we can make sure that it will always happen no matter what, and we can never forget that if check by creating a setter. So we have public int get health. So this is public, health is private. This just means that everything can still find out what the health actually is with a getter, but you can no longer access object.health directly because that would be sort of unsafe. And this is now the only way we can set health using the method take damage. We provide a damage value, a damage type, and to make sure that if this type equals this type, then we have the damage. Because in this world, just to keep things simple, we're just going to pretend the Pokemon is resistant to its own damage type before subtracting it from her health. So now we have control of the way health is set. Saying abstract class is the same as public abstract class, right? For all intents and purposes, yes, classes can receive access modifiers, but what access modifiers do on a class definition affects the way it interacts with packages. Instructors seemingly have not taught packages in the semester, and I'd be very surprised if they introduce it now. So for all intents and purposes, you don't have to worry about access modifiers on the class. What type of variable is type? Oh yeah, I should go over what final means. Final just means that final means that whatever member is, whatever variable this is now a constant. It can be set in the constructor once, and it can never be set again because, it's a constant. And in Java, it is standard to make all constants written in all capital letters. Type is a string, so this hasn't changed. We can always declare what type things is by putting it before. So type is still a string. We're putting in a string type in the constructor that goes here. So Pikachu's, for Ivysaur, for example, is grass. We set type as a grass, it comes in here, goes in here, and then it's set over here, and here it will stay. We can no longer set type after it is set because it is final, but we can still get it. I will say, though, that for this implementation specifically, for this kind of game, it would be better to use an enum for type, but we're only going to cover that if people feel like it. What else? Oh yeah, abstract. Abstract just means that we can no longer instantiate this class. What that means is you can no longer say new Pokemon, or specifically new Pokemon. Like you can still instantiate Ivysaur and Pikachu instantiate as in the same thing as construct, call it the constructor. So these guys can still be instantiated, just not Pokemon itself. This is because the generic Pokemon never actually exists in the game. You don't get to see the base type that every single Pokemon in existence inherits from. So that's behaving as we expected. It's just restricting the way we can use this class. And so in other words, just getting rid of another way that people can do wrong. Something unique to abstract classes is the abstract modifier on a method. If a class isn't abstract, we can't have this. Abstract on a method just forces non-abstract inheritors to override it. What's a non-abstract inheritor? Well, it's anything that extends the Pokemon class that doesn't have abstract on it. For example, Ivysaur extends Pokemon, it's not abstract itself. That means that if it doesn't override attack, the compiler is going to throw a fit. So this makes sure that every single Pokemon that exists will always have its own attack. And everything would behave as we expected. So before we go into taking a look at where all of these concepts are cropped up in A1, let's take a look at it. We'll take a look at the runner class just to make sure, and take a look at some of the questions in the run class. Can an abstract class extend another abstract class? Yes, abstract classes can extend abstract classes. Good question. So here I've prepared a series of statements that will cause the compiler to fail. I'll just do the first one so that we know what kind of pace we're at. So Pikachu is a new Pikachu. That's fine. It's just constructing a new one. It's calling this constructor that exists. Everything is fine. Then we attempt to say Pikachu.type is electric. This would fail because, well, let's take a look. So we're calling Pikachu.type. That means we expect there to be a variable here that says type. We don't see one, but we do see that Pikachu extends Pokemon. So yeah, it should probably be in here. And yes, here it is. Accessing it isn't a problem. Public is here. That means we can still call it with this syntax. But final is here. That means that once it is set, it cannot be set again. And once it's set in the constructor, it can't be set again. Yep, this would fail because type is final. Type is a constant. You cannot assign a value to a constant. That is why that line will fail. Does anyone know why this one would fail? I'll give it a few seconds. All right. The way that this, yep, thank you, Philum, you got it. You cannot access private variables. That is correct. Health is private in here. And yeah, perfect. You're one step ahead of me. Nice. So the way we would fix this is we would change this to the public getter. And the reason, again, why health is private at all is because we want to make sure that each time a Pokemon takes damage, we always want to check whether to apply resistance or not. So yeah, this fixes it. We're calling the public getter, and everybody is happy. Now for this one. Can you repeat why health is private? Oh yeah, of course. So we're making health private because we want to control the way it is set. There is never a case in where a Pokemon would lose health and in a way that we don't want to check for resistances and weaknesses. So every single time a Pokemon takes damage, we always want to make sure that a type has been provided with a damage and the Pokemon is not resistant to it. Let's just say that we did make health public. So now each time that we write a damage method, so where's the Pikachu we modified earlier? Here, so let's say that we have this one here, attack a Pokemon target. I guess you could say, add something like you technically could just copy this if statement over here each time we add that. So if type is equal to type is equal to the type of this attack, which is perhaps an electric attack, we would multiply the damage by 0.5 equals the type of this attack, and then we actually apply the damage, so target.health minus equals damage. And we can do this for every single attack method that will ever be called, but that's just lots and lots of copy pasting of this one if statement. It's much better to put it in this controlled environment. We can make sure that the only way we can ever set health is through this setter. So getters and setters, they're just specifically designed to control the way data is accessed. In this case, we're making sure that each time we ever wanted to change health, we have this check before it. So that is the point of the setter. There's no other way to change health now. I hope that makes sense. All right, when the child class inherits a final variable, can the final variable be changed? Final is honestly very, very funky. Final is, it depends if final is set here or not. My own understanding is final is pretty nebulous. So I'm pretty sure that if I were to like put something in final here and we try to compile it, it's just going to say that we cannot, Pokemon 17. Yep, we cannot assign a value to the final variable type. So here, once you can think of final variables as they can be set once, and once it's set, you can never set it again. So in this case, we're setting it over here, but then we try to set it again in the constructors, so it's not being, so that's why the compiler is messing up. For a child class inherits, can it be? But it doesn't have to be the Pokemon class that sets it. So for example, if we don't set it in here and we have it set in Pikachu instead, so we're passing electric, but then this type is equal to, we're doing the actual set over here. That is perfectly fine because it is the first time it is being set. Hang on. Variable type might not have been initialized. Well, I guess you can only set it inside the Pokemon class. Yeah, my understanding was pretty nebulous, but there's our answer, I suppose. You can only set it when the class is being constructed, and after that happens, it's never set again. So if it is in Pokemon, it cannot be changed within Pikachu. I learned something today. No problem. So at this point, we have covered inheritance, encapsulation, constructors, static, and classes, and that is all we need to fully understand what is going on in assignment 1. So everything here is private. That much makes sense because Dataset is the only class in the, because everything in the utilities class doesn't really need to access these private members of the static of Dataset. These are like exclusive to Dataset itself. The way we interact with these values is through all the public methods we have here. So that makes sense. Why these things are private, static, final is because these are like fully constants. This will never change throughout the entire running of this program. Quote mark will never change throughout this entire program too. The reason why there's this weird backslash here is because this is a skate character. And what it does is that it makes this quote treated as like a literal quote instead of one of the quotes that tells the compiler, okay, we want a character now. So those are our two constants. We just like to have constants because if we see like a random comma character down the line, instead of like say a delimiter, we don't actually know it's a delimiter. So character equals comma. You can do that. It's just a bit weird because that's a hard-coded value. This just makes things more readable. That is these two constants and why they are private, static, and final. These ones are just data that are manipulated by the public methods. Let's just go over what happens when we run Dataset. So we have a file name, whether with spaces, that's being passed over to the Dataset constructor, which is over here. So first thing it does is it calls calculate dimensions. The reason why I can call this is because it's private, it's accessible to this class, string file name. Yeah, it just sets, it does a lot of shenaniganery, but in the end, it just sets what num columns and num rows are. Count columns was actually a bit of a surprise to me because count columns is private and static. Since it's private data set is access, that much is obvious, but the reason why it's static is static has sort of a second purpose when you put it on methods. It makes it so that this method scope, so everything inside this method, no longer has access to any of the instance variables of dataset. So from within this method, I can no longer access, say, what num columns is, what num rows is. Count columns, all it does is that it gets that file, it counts the number of, it gets this line, it counts the number of columns in that line and returns that number. It doesn't need to access any of these, which is why it is static. But since also that this is a static method, it can access all of the static variables in this class, all the class variables of the class, which happens to delimiter and quote mark. So these are okay for static methods, these ones are not. That is private static explained. So once we've calculated dimensions, that means num columns and num rows are now set. Then we just, now that we have these, we can initialize the size of attribute names. We can also initialize the size of the matrix now that we know the dimensions. And then we call instantiate from file, which just populates the array. And all of these are possible because are you private? Yeah, because it's private. It's also from this class. I mean, I suppose you can call the public ones as well. The reason why some of these methods are public is because more or less how the JUnit testing works, automated testing, is imagine that it like puts a new class within this folder as well. And it needs to be able, and once it constructs dataset, it runs a whole bunch of methods on it just to test the output is correct. And to let it have access to the methods that it wants to test, those ones have to be public. So that is why some of the methods within the dataset are public. Those are the ones that are tested by the grader. If it's public static, we can only use static variables as well. Yep, that is correct. Static makes it so that a static on a method means that it can no longer access the instance variables within the class, which kind of makes sense because imagine you had two different data sets and one of them had like a different set of num columns, num rows, et cetera, et cetera. One of them had a different set of instance variables. But so if you were to like have a static method, which is associated with the class itself, you don't really know which one of these it kind of wants to refer to. So all static methods can only access the static properties within the class. No problem. Util class is pretty standard. Everything here is public static. It doesn't have, everything here is public static, so everything is called using util.something something because it is a utilities class. It should be accessible from anyone. I personally don't really like having utility classes because, you know, it's not really modular. It's literally accessible to everything. It kind of goes against the principles of encapsulation, but I guess that made sense in this case. Alrighty then. Are we all cool on encapsulation? So if there are any questions about any of the keywords that you see on this page, we should get over them now because everything here is, I would expect you to know them going into polymorphism. I will take that as a no. So let's move on to polymorphism. All of these classes are still the same thing. The one thing about it is that IVSOR now has a method that only IVSOR has and Pikachu doesn't. This is the method being cut. Pikachu has flash that IVSOR does not have. So those are the only changes. Pokemon, I've removed all the comments, but all the access modifiers are still the same. But what has changed is what I'll be doing in the runner class. So take what polymorphism does is, no, that's not a good way to explain it. Let's start off like this. In Pokemon, you have a party of various monsters that make up your team, but you want to store them all in the same collection or the same array so that you can loop over them for area of effect effects or say healing at a Poke Center. So you don't have to, you know, Pikachu 1.heal, Ivysaur 2.heal. That's just going to give you a migraine. So it's really nice if you can store them in the same collection. But remember that what the problem is, there are different subclasses. So you can't just say an array of Pikachu can constitute your entire party. But what we can do is say Pokemon party is equal to a new Pokemon array and perform some implicit upcasting. And we can talk, oh, hang on, there are some questions. How do you call a static method skin in the main? static is always associated with the class. Static is always associated with the class itself. And so instead of using what the object's name is to call it, we use the syntax of the class name itself. So Pikachu.attack count references the static attack count here. If we say like public static void attack, then the way we would call that is Pikachu. So static always associates things with the class name itself. This is how you would call a static method. That make sense? Cool. Where was I? Oh yeah, polymorphism. So yeah, polymorphism is polymorphism lets you cast subclasses into the store subclasses in a collection that's declared to store their superclasses, and that is how we get them in the same party. But in general, polymorphism is the ability of an object to take on multiple forms. We've seen in inheritance how methods can be overridden. Polymorphism basically lets us call those overridden methods in a really cool way. So we know that even though we've stored Pikachu and Ivysaur as a data type of Pokemon, Pokemon still has a method signature for attack. So when we call attack on the Pokemon in this party, it actually knows, the compiler knows to call the attack that's inside Pikachu and Ivysaur, the ones that have been overridden. That saves us from a lot of like if statements to like check, okay, if this Pokemon is of a type Pikachu, then we do this and this, etc. So that's more or less what method overriding and polymorphism combined is getting rid of. Upcasting, oh, hang on, let me grab the UML again so I can describe, so that we can see visually why upcasting and downcasting are called the things that they are. So when we want to cast an object, the syntax is just having the name of the class that we want to cast to in brackets before the actual class that's being instantiated. So even though we're calling a new Pikachu, we can store inside the Pokemon class because we're casting it as such, and you can see that they are related. And likewise, we can also cast this new Pokemon. So Boop is stored as a Pokemon type back into a Pikachu using this syntax and use a method that is only in Pikachu and not in Pokemon in this manner. There are additional rules for casting like win or fail. For example, if you were to try saying Ivysaur Boop dot cut, that wouldn't work because this uses the Pikachu data type. So, yep, just verifying that upcasting going from Pikachu to Pokemon with this actually works, as well as downcasting going from Pokemon back into Pikachu also works. The main benefit of being able to like move between superclasses and subclasses like this is being able to store different subclasses within the same collection that stores a superclass. And everything still behaves as expected. So we can literally loop over them and call attack on each of them, and it knows to use the overridden methods. We can also loop over them and call take damage, and this will change each of their instance variables as well. One way that we can know, but this can lead to some ambiguity. So if you do have like a whole bunch of subclasses stored within a collection that operates on the superclass, you don't actually know what the actual type of those the things stored inside it are. And the way we check is using the keywords instance of and get class. Oh. I guess we can keep here. So instance of checks if the type that you're working on is an instance of either the type itself or any of its superclasses. So Pikachu is an instance of Pokemon because, Pikachu is a Pokemon. But Pikachu is also an instance of Pikachu because, well, that's just the class itself. It is not, however, an instance of Ivysaur. You can just think of instance of whatever is passed in here, take a look on the charts, and then see if the class that you're comparing it to falls on any of the lines above. So it just has to extend something to be an instance of that thing. And yep, so the first one is, we don't need you. The first one is true, and the first one also happens to be Pikachu, so it is an instance of Pikachu, and the second one is false, because Ivysaur is not an instance of Pikachu. So when you call it Pikachu boop, is it still a Pikachu after that line ran, or is it set back to Pokemon? A good way to think of casting is the data itself never changes. The data type is like a buffer between the actual, what's actually stored in memory of that class and how it is accessed. So when you cast boop as back into your Pikachu, it is still a Pikachu after, I see what your question is, never mind, my bad. So boop is still a Pokemon, even though we get casted this as a Pikachu, boop is still considered a Pokemon because we never actually changed its type. If you want to change its type, you can say Pikachu, I don't know, beep equals boop, and now this would be, this would actually have this type change, but no, merely doing this cast syntax doesn't actually change anything about the way it is stored in memory. Will the recording be available after the review session is over? I'm recording on my computer, so I suspect I'll upload it and then just share it on the Discord, or send it to the DSC channels. Okay. So a cast itself does not change anything about the way it is actually stored. I hope that makes sense. So we've covered instance of. It just checks if the thing you're comparing is a member of that class or any of the classes above it. So if we want to, we know that both Pikachu and Ivysaur are Pokemon. So just verifying that is true because they both extend the Pokemon class. And better time when using get class would be better than instance of. Oh yeah, I'm going to cover that. Get class compares the class directly. So if you were to say is Pikachu.getClass equals Pokemon.getClass, that would fail. That would return false. So it no longer checks whether it is an instance of itself or any of its superclasses. It's only checking if it is an instance of itself. So they function differently. So their use cases are pretty differently. So yeah, there are many times when using get class would be better than instance of. Is everything clear? The main concept that you should take away from polymorphism is that you can store subclasses within collections of the superclass. Well, if you do think of questions, we can always head back. Oh yeah, let's take a look at lab 4. This makes use of the concept I was talking about, storing subclasses within collections of the superclass. Because now we have newsfeed, photo posts, posts, and text posts. These are still the same as usual. But within newsfeed, we actually have an array of type post. And this means that this array can store both photo posts, posts, and text posts. And that's exactly what happens. So when we add a post message, since this is taking in a post, we can actually say things along the lines of add text post, and it will get implicitly upcasted into a post before being added so that it can be stored within that array. Everything else more or less operates along that concept in newsfeed. Here is an instance of photo post being used. So public newsfeed get photo post. What this method does is that it goes through all of the posts that it is storing. If it happens to be an instance of photo post, it adds it to the new newsfeed and returns that newsfeed. So that is just an example of how we can use instance of. Everything else seems pretty standard. Likeable is an interface that all of the posts use, which is a really nice cube because we're talking about interfaces next. So, oh, that's the wrong UML. Hello. Let's keep that always visible. So imagine we want to do some work on the overworld. And on the overworld, there's a whole bunch of stuff you can interact with. There's lootable chests, brawlable trainers, and petable Pokemon. And all of these would need the same method in common. Interact, something that is called when the player wants to interact with any of them. And all of these need to be stored in the same data structure. So the benefits of doing that is that you can loop over them to load them all at once when we're doing scene transitions, unload them all at once, or just keep track of which ones have been interacted with. So it'd be real nice to store all the interactables on a world map, the same way that it's real nice to store all the different types of Pokemon within the same array for your party. And the way we do that is with interfaces. And what interfaces do is they take the concept of abstraction to the next level. An interface specifies what must be done, but not how to do it. So methods in an interface are just definitions, and variables created in an interface are always treated as public final static values. But considering how none of the examples the professor has given of interfaces have ever had variables in them, I don't think that's too important. So interfaces are great at specifying the required methods for a class, but leaving the details of how it works to the programmer. Also, interfaces can extend other interfaces, and although classes can only extend one class, they can implement as many interfaces as they like. So let's take a look at what has changed. So now, both Pokemon and Trainer implement interactable because they're both Pokemons and trainers in the overworld. When Pokemon implements interactable, it must override, since Trainer implements interactable, it has to override the method interact because it is all methods within an interface are considered abstract. So if you're implementing an interface, you must override these methods if your class is not abstract, which is what Trainer does. Since Pokemon happens to be an abstract class, it doesn't have to override interact, but every non-abstract subclass of Pokemon must override it. Example given, why are you implementing interactable is nothing is being done in it. Something is happening when we implement interactable. When this happens, you can think of it as this method is inherited by Pokemon, right? Because like you're implementing it, that's more or less the same thing as extending class. And this is a member of the class, so we can pretend it is here. That would be exactly identical to having not implemented interactable. And since it's here, Pokemon has things that inherit it. This means that Pikachu and Ivysaur must now implement interact. So this is now standard. If you want to extend Pokemon, since it is now implementing interactable, it must also override this method because these Pokemon classes are not abstract and they are subclasses of a superclass that has abstract methods. So this basically forces Pikachu and Ivysaur to override the method interact. I hope that makes sense. So if it's the same thing, why not just put that one line of interactable into the Pokemon class? Why not just put the one line of interactable into the Pokemon class? Because if we didn't implement interactable, it would not be possible to cast this into a data type as we see in the runner class. So here, take a look at this. We have an array of interactables but the key thing is it can store both trainers and subclasses of Pokemon, even though these don't have any superclass in common. So previously with polymorphism, we learned that if multiple subclasses all have the same superclass, they can be upcasted so that they can all be stored within that collection of the superclass. Here, even though trainer and Pokemon don't have a superclass in common, but have only one method in common, that method being defined in the interface, they can all be stored in here and used as if they were that interface. So now we have a whole bunch of MVCs that are all interactable. At this point, we have covered so much content that almost, let's say like 90% of the work assigned in this course can be gone over. So yeah, here everything works as expected. We're storing an array that contains both trainers and Pokemon, and we're interacting with each of them, and they all behave as expected. So we call trainer.interact. It uses the override of interact and trainer, which is here, which is printed here, so on and so forth for the two Pokemon. We can cover a lot of the labs and assignments now. I think it'd be good to start with Lab 5 specifically because it seems to have been optimized for teaching interfaces, and I think it's pretty good at doing that. So here we have the interface series, public abstract double next. That means that any non-abstract class that implements series must override next. And here's abstract series, and we see that this implements series. But notice how it doesn't actually override next. That is because it happens to be abstract itself. This means that anything that extends an abstract series must implement next. And that is exactly what geometric and arithmetic do. They extend next. Everything makes sense? Oh yeah, and also for the JUnit, you can imagine that the JUnit would probably like instantiate geometric and instances of the geometric and arithmetic classes and then just call next on them.
What are you studying for?
Pardon? Okay. Now we can also take a look at the question 1 on the midterm. Even though the question 1 on the midterm involved an interface, I don't think it really used it that much, but it's still an example nonetheless, and a quick one, so we can take a look at it pretty quickly. So we have this interface deep copyable, and all methods, even if it's not said explicitly, they're always public and abstract. So anything that implements deep copyable has to have override the method deep copy. Both A and B implement deep copyable, so this is now standardized for them. They both implement the method deep copy. And when we test deep copy, we can see that we're calling that method here and here for B and A, I suppose. And at this point, I think we've also covered more or less how to read a UML. If we have a solid arrow, this implies that a class extends another class. If we have a dotted arrow, that implies that a method implements another interface. So here, we can get a pretty good idea of how AT works just by looking at the UML. So we see that in A2, we have a dataset class that happens to be abstract because the abstract data class doesn't exist, but it is used as a framework for virtual dataset and actual dataset. This just makes, because both of these should be interacted with in the same way. They should both be treated as if they're dataset. But the person who's using dataset shouldn't really have to worry about whether it's actual or abstract. Oh, hello. Can we have an array of both interfaces and abstract classes, but not a variable? Is that correct? You can you can store them as their superclasses if you would like. So, for example, here, Pokemon is an abstract class, right? But we can still store an instance of Pikachu inside it because it happens to be a subclass of Pokemon. So we can upcast it into a Pokemon. Same goes for an interface. So if in here, just like the upcast we performed in here, we can say interactable is the same thing as interactable new Pikachu. This would compile just fine as well. So it doesn't have to be an array, but Doesn't have to be an array. It could also be like a linked list or any other collection. It's just a really handy way of storing all the subclasses and inheritors in one. So you can have a variable them. It's just not as useful or funky as having them all in the same collection. Okay, so the dataset class, this just makes it so that when people work with datasets, they don't have to worry about whether it's abstract or virtual. All the methods that they need are in here. This funky little black diamond just says that dataset holds instances of the attribute class, and yep, they're in here. Can we have an array of both interfaces and abstract classes? We cannot say interactable is new interactable. No, we cannot. You cannot instantiate interface. Good question. Abstract classes and interfaces cannot be constructed or instantiated. They're just used as a way of controlling the way we access the data that is controlling the way we actually work with the things that we construct. No problem. The interface in A2 happens to be data reader, and it is implemented by CSV reader. So in data reader, this contains all of the things that we use to, all of the things that we'd expect to get from something that has to do with file.io. I found it strange that they only had a CSV reader in A2 and not anything else, because honestly, you could have just gotten control, copy, pasted every single instance of data reader with CSV reader in this project, and everything would still work perfectly fine. I feel like the reason this interface exists is so that it adds support to if we want to work with different file types. For example, we have XML reader alongside CSV reader. So now A2 would be able to handle both XML files and CSV files. And all we would have to do is switch around the one that actually gets instantiated in the main of A2. Can we actually find that? Let's see. New dataset, new. How did these both take in CSV reader, not data reader? I guess that was added in A3 or A4. But yeah, in general, the existence of the data reader interface implies that it's just helps the project support adding XML readers in the future, everything of that like. Everything else should be pretty self-explanatory. Yep. Oh, I should mention what aggregate means. Composed of means that dataset composed of and aggregate are very similar. It's like they contain one of the other. Composed of just means that a bit more literally. So dataset actually has an instance of attributes here, but virtual dataset doesn't actually store actual dataset. It just operates upon it. That's why those two exist. I don't think UML is going to be actually tested, but the main important ones is that. But I figured it'd be cool to touch upon it since we already learned most of the basics just by looking at the UMLs for our Pokemon game. So those are interfaces. It's just the same thing as abstract classes, but taken to another level. If you think of any questions, we can always go back. So lastly, let's take a look at generics. In Pokemon, every single monster can be given a little item to hold, but the difficulty lies in how the behavior of the items can have absolutely nothing in common. So it doesn't make sense to have them all extend the same class, all the items extend the same class, or even all implement the same interface. For example, in Pokemon, you can have berries and EXP shares, but the way these two things function are completely different. Berries, a Pokemon will automatically eat a berry if it gets hurt. EXP share means that at the end of the combat, a Pokemon with an EXP share gets to share in some experience points gained by the Pokemon that actually did the fighting. So they have nothing in common, and yet generics lets us work with them both because Pokemon should still be able to hold either. And here is where we start to see some of those triangular brackets that may have confused people in the beginning. So with many, many asterisks, what generics does is that it lets you pass in a type when you construct a class. So here we can say that, okay, well, I want to create a Pikachu that holds a berry, and we just pass it in the, and the syntax goes along the, and the syntax to do that is here. So Pikachu that operates on some generic type, parameterized type, extends Pokemon that also operates on that type. And basically what happens when we're calling it like this is you can think of it as every single instance of E that has showed up in these classes has been copy and replace it E with whatever was passed in. So in this case, all the E's get replaced with berry, so on and so forth. That just means that this class, this instance of this class specifically that you constructed now works with berries. So yeah, you see that this Pikachu has to hold a berry, and then you can see that its held item is a berry. This will cause no problems at all. You won't. Same thing with the Ivysaur, except we set this one to work with EXP shares. And another time where we may have encountered generics but not realized it is whenever we created a linked list. Remember these being present in assignment 2 and assignment 3. So we say that there's a linked list of type Pokemon. This just means that for whatever the linked list class is, each time that E must have showed up in those like triangle brackets that have in that class are now replaced with Pokemon. So this class, this linked list, now operates on the Pokemon data type. Then we can add Pikachu, Ivysaur, and then do whatever we want to this collection. Everything looks as expected. There you go. Let's see. Can you change an object's held item? In other words, their generics? Once it is constructed, it's very uncommon to do that. So admittedly, this is not the best way to implement this for this game, but it is the best example I can think of for this project. So, I mean, maybe. One of the weird things you can do is you don't actually have to specify these, but that is considered an unsafe or unchecked operation. Pretty sure that, yeah, so uses unchecked or unsafe operations. What's going on here is that the compiler is panicking a bit because it knows absolutely nothing about what type you're working with, specifically in the Ivysaur class. Compilers like to know what type you're working with so it can catch errors and exceptions for you, but since you never gave it the type, it can't do that. So it's going to just kind of reluctantly compile anyways. In this case, it's fine because you never actually do anything to the held items because implementing those would probably like detract from me focusing on OOP. But if you did do something for the held items, for example, if EXP share had a method, you could still call it by casting it as an EXP share first, but that's unsafe because the compiler doesn't know if the cast will actually work because it knows nothing about what kind of type you have specified in here. Actually, I'm a bit curious. We changed it here. It's still compiled. Oh yeah, it would. So if you don't specify a type, technically you can change an object's held item, but the only reason why this works is because we're not actually doing anything to them. It's always nicer to specify the type when we can. Benefit of using generics. It lets a class operate on, it basically lets you pass in a whole type when you construct that class. So you're telling that this instance of linked list specifically is going to work on Pokemon. The alternative, I guess, would be, or the closest thing you could compare it to is getting rid of the generics and saying public object or item. So yeah, technically everything would still behave as expected because all classes are secretly subclasses of the superclass of objects, of which you can read about in the documentation, because object actually does have a toString, so every toString you ever write overwrites toString. This is why when you print out system.print out a print line, an object, it actually calls object.toString secretly. But yeah, this is the closest thing to generics, but what it does is that if you specify the type, the compiler can catch errors ahead of time for you. That's more or less it. It just makes your code a little bit more safe, kind of like encapsulation. So say EXP share had a distribute or something method, and we didn't specify with it. If we try to call the method, it would break because it's confused. If you just try to do something with EXP share and you don't specify any type at all, I'm pretty sure it wouldn't compile. Some sort of exception would be thrown. but you can downcast into an EXP share. So let's say IV sorter, again, we don't actually tell it that it has an EXP share, and it does have a method called distribute. You can still call IV sorter.held item, and we cast this as an EXP share. And we do this because we know that secretly this item is an instance of EXP share, and then we call that distribute. So it's still possible, but it does involve a cast. But like downcasting is always a little bit unsafe, because what if this doesn't have to happen to be an EXP share? Then your code's going to crash and burn. And the way we get rid of that possibility is explicitly saying that it is an EXP share. And this way we can call item without any problems at all. No problem. And good question. All righty. I think that is it for the crash course. Are there any questions from any other sections that people would like me to go over? Linked lists? Yep, we can do linked lists. Where can I find resources on linked lists? Are there any parts of linked lists that you would like me to explain specifically? Previous exam. You know what? I think that's probably better. Let's find an exam that, are you guys aware of final exams that go over both linked lists and binary search trees? Oh yeah, sure. We can do that while I look for an exam. So, general idea about linked lists of dummy nodes without dummy nodes. I worry about explaining those because dummy nodes build on a lot of concepts that a linked list operates on already. You know what? Maybe I can give you a general rundown of how a linked list works. So let's just start off, let's just teach by comparison. So we have an array, right? Arrays work by, you can think of them as they're kind of stored in memory. They're stored in memory, and then you use an int to access each of those slots. It's already all pre-allocated. But the way a linked list works is that it's made of nodes. And what a node does is a node stores a value, but it also stores the node next to it. So you have all of these nodes scattered around in memory. And when you create a linked list, there isn't that set size anymore. You can have as many nodes pointing at each other as you want. Each time you want to add something to a new linked list, you create a new node, you get the old node to point to that, and that is how a linked list works. And since they're pointing to each other, you can get any element that you want. So if you want to say get 3, then you take a look at what the first node has, and then you go to traverse to that node, whatever node that this node is pointing at. So it's 2 left, and then 1 left, and that would be your get 3 on a linked list. So it's just a bunch of nodes connect to each other, link to each other. That is why it is called. That is what a linked list is. Dummy nodes are basically so there's a lot of different kinds of linked lists. For the first node, the head of the linked list, if it's a dummy node, that just means it doesn't store value. Like you're not using the head for anything except for just creating a head for the linked list. I guess that's why it's called a dummy node, because it doesn't actually store value. 2018 exam is a BST, stacks, node, and linked list. That was a lot of questions. 1 second. Would you be able to go over binary trees? I'm pretty sure one of the exams is a binary tree. When would using linked lists? Generics with arrays. Generics with arrays? That is very tricky, because if you try to create an array that works on a parameterized type, when you create an array, you're actually physically allocating memory for each of the elements of that array. When you have a generic type for that array, the compiler doesn't know what that type is. For example, if the type is an integer, then it's only going to allocate the space for an integer for each of those slots in the array. If it happens to be double, it would need even more space. The compiler doesn't know that, so it doesn't know how much memory it actually needs to allocate for the whole array. That is why it's always kind of iffy to use generics with arrays. When it does work is, say, like you have that array of a random type, and you start off with an object array, and you cast it into that generic array. So now the compiler just goes, okay, well, I can create space to store a reference to each of those objects, and that would work perfectly fine. When would using linked lists be more beneficial than using queues? Queues are more restricted than linked lists. Linked lists, you can more or less access any part of the linked list that you want, right? Queue is like first in, first out. You're only able to get the first item that you put into the queue, but you can't get anything else. If you wanted to, like, say, get the third element of the queue, you would have to like take the first one, discard the second one, discard it, and only then would the third one be able to be accessed. So queues will almost always be more performant. Linked lists are just more flexible, I suppose. They're a better replacement for arrays. If you can use a queue, it is almost always more performant, but more restrictive. So you could generate cans not to act really funky, which is why you don't see it often, but I'm pretty sure it's possible. Yep, that's what I meant. Like if you have an object array and you cast it into a generic array, then those references are all, and then you're basically storing an array of references, and the references point to the actual data type that you're storing. 2018 has BSD stacks and nodes and lists. 2019 is binary trees. I do know the last review session covered midterms. I'm pretty sure 2019 is more relevant. Question mark. So maybe we can go through both. Let's take a look at 2019 first. Take a look at how the links, they're all red. I haven't opened any of these before. Okay. Yep, yada, yada, yada. Okay, well, let's go for 2019 then. Question 1. Implement the instance method merge for the class linked list that has the following characteristics. Let's always start with a dummy node so that marker for the beginning of the list. Okay, yeah, so here's dummy node again. That just means that the node doesn't store any data itself. It's just used to store the node after. And if it's doubly linked list, it also stores the node before. Dummy nodes don't store data. Empty list is made up of the dummy node only. That's given. This implementation of the question the nodes and the list of doubly linked. This implementation list is circular. So in other words, the reference from the last node in the list points to the dummy node. And okay, so it's like a donut of nodes where all of the nodes point to each other, both forwards and backwards. So from any node, you can also access the node that's before it and the node that's after it. That makes sense. Last node is easily accessible because it is always the node preceding. Yeah, that's a given. So the head, or in other words, the dummy node dot previous will give you the last node in that linked list, and the head dot next will give you the node after it. After the header of the list does not have a pointed tail element. Oh yeah, that makes sense because each node has their own element, their own data type, but yeah. Method merge adds all the elements designated by the parameter other to this list. After I call to the method list, the list designated by other is empty. In my head, I want something to physically demonstrate like my visualization of these lists, because let's take a look at everything else first. Oh, it's fill in the blank. That's interesting. It'd be really cool if I had 2 pieces of yarn to show what I have in mind. 1 second. Because I more or less already have a good idea of what each of these lines is supposed to do. But all I want to do is have a nice way of explaining it for everyone else. Very visual, I suppose. For all intents and purposes, let's just say that a piece of yarn can be considered a linked list. So where I pinch it at the top, that can be considered the head of the linked list, and things that go, and the next node goes this way, the previous node comes here, and then links all the way around. We don't have to worry about any of the connections within the node themselves. We're only concerned about what's happening at the head. So if we have a second linked list, the other one in this case, what we want the end product to be is something along the lines of this. Everything in other gets added to what was originally in this one. So here we see that we're going to need to, 1 second, how many lines are there in total? Because I need two. Yeah, we only need to worry about what's changing at the heads, what's changing at this head and what's changing at this head. In other words, what's changing is this hub.previous gets set to the other linked lists last. And at this head.previous down here starts pointing to the other lists first. So let's see, we have an if. This is probably just a null check. I'll add that at the end. This last, other first, other last. Is there an annotation that I could use? Annotate text. Cool. So this dot last, this is pretty obvious. Other first. This turns into other dot head dot. Oh yeah, if you're worried about like accessing things, the reason why this works is since this is all within a linked list itself, even though head is private here, since other is also a member of linked list, we can actually access other.head, even though it's a different instance, just because other also happens to be a different linked list. Also, we have this nested class in here. What a nested static class is the differences between a static inner class and a normal inner class are pretty subtle, but I don't think we have to go over it for the purpose of this question. But inner classes, everything within the inner class is accessible. Okay, back to the question. Previous. Other first is dot next, other last, other dot head dot previous. These three are cool, right? Everyone understands? Just because of the way the linked list works. If I'm pinching the head, the next one is over here, which happens to be the first element of the linked list, which links all the way around to the back. So head.previous points to the last one over here. Something is equal to this dot last. So we're setting something to head.previous. Now if we take a look at the final structure, that means we want to point something to this dot last, which happens to be over here. And what points that way happens to be the others first. So other first dot next now points to this. We're only worrying about this connection right here, the one where the end of the first linked list points to the start of the second. Dot head dot next is equal to next. Other dot head dot next or previous points to this dot last. Oh, we can simplify that actually. Other first dot previous is equal to this dot last. Yep, you're right, we caught that. Thank you. And I'm assuming that everything is going to go in order. So something else is going to be set to other dot first. And yep, that confirmed my suspicions. That is worrying entirely about the connection where we're setting this dot last to other dot first. So this connection is almost entirely done. We just need to set the other linked list's head. We need to set the references. The other linked list dummy node needs to point to null in both ways, just to say that, okay, this connection has been made. Oh, that is done. Other dot head equals null. I'm assuming that's just going to be the same thing over here. It's also equal to null. So if this is worrying about the connection node, down here. And that means the next two lines are probably going to be worrying about the connection up top. And there's still 2 lines missing, but I'm assuming this has to deal with changing the sizes. So let's just do that one real quick. This dot size is equal to other dot size plus this size. Size is equal to 0 now that we've taken everything. So we update size. Last one, other dot last. That is just dot previous points to other dot. Dot previous points to other dot last. And yeah. So yeah, at this point, we've just made the connections. First 3 lines, they're just like creating local variables to help us out. The next 2 change the next 2 lines, worry about this connection here. And the ones after that, worry about the connections up here. So now the loop is entirely formed. Then we're just taking we're just updating the sizes and setting the other heads to null. Can't you use other first dot previous? For which one? Other first dot previous. Where is other first? So other first is over here. Other first dot previous. Oh yeah. Good catch. You can tell that usually I don't bother with all of this. Like you can do everything perfectly well without needing to set those locus variables, but it is nice, I suppose. Yep. For other head dot next, shouldn't that point to other dot head? Nothing should point to other dot head. When we get rid of when we're merging these 2 linked lists, I think it said earlier up there that other should just have nothing left in it, as we saw in the output. Like the array was just simply empty. So nothing should be pointing to other dot head. Other head shouldn't point to anything left. This linked list has all of its data yoinked and put into this one. Oh yeah. Oh, I see what you mean. Yeah. Oh no. Answer is other dot head. Oh, hang on. Why is other dot head dot next? Oh, that is a lot of texts. Which ones of these are still relevant? Dummy node is a head, so when it's empty, it should loop back around. Oh yeah, true. That is true. It should point as itself. Thank you for catching that. So those do not point at null. Whoops. Zoom. Okay. Why does that erase? Oh, it's probably fine. Good catch. Thank you, everyone. Yep, those make sense. So now the other one is circular. Oh yeah, we still have to do this condition. Well, the other one, the proper solution to this exam, then maybe I shouldn't be going over it because you can just check that one instead of mine. Or I should just answer specific questions about each of the questions here. So other isn't null, and other dot size is greater than 0, I suppose. Everything here makes sense? Cool. Let us move on. Oh yeah, please tell me if I'm covering a question that nobody actually needs to know the answer to, because we can speed things up. how can you tell when you're changing the value of a node versus what it's pointing to? Changing a value. Until previous is equal to the value of a node. I'm assuming you're not referring to. Are you referring to this value of the node? Because what it's actually storing? Head.previous is equal to other.last. Oh, okay. The value actually has nothing to do with all of these node references that we're doing. The value in here is whatever the node is storing. So if the linked list is storing, say, strings, say strings, then the value is just like a string, some sort of string that someone put in the node. So it would be storing things like Alpha, Bravo, Charlie, Delta. It's not actually storing references to other nodes. That doesn't have much to deal with worrying about the connections. Thank you for letting me clarify that, though, and I hope that helped. Okay, no problem. Question 2, complete the implementation of the method find replace for the class linked list on the next page. Smells like recursion. This method replaces all occurrences. It is a recursive method, thank you. Please know that the list is simply linked and there is no dummy node. Oh, it's more fill in the blanks. Okay. Somebody mentioned the professor's solution. Could they show me where that solution is? It might be faster for me to explain what the solution is instead of like doing it myself and having people correct me. Didn't give the lecture recording. Okay. Do we feel like we need to review recursion? Because recursion is mostly problem solving. I would probably, well, I know that since this is recursion, I would have to, the base case would probably be when the node.next is equal to null. Like when the node.next is equal to null, that means that you have hit the end of the linked list, you have found and replaced everything that you wanted to do. Oh, perfect. Thank you. We can take a look at this instead. Just for the sake of time. Oh my goodness. You have the class to work on. Question 1. It's much more. No, so we only did question 1 and question 2. Okay. Running the program on this. Let's quickly grab a screen cap of this. Alrighty. Wait, there's no actual solution to this question here. That is fine, but each time I see any question about recursion, we know that it's just, if you're taking discrete mathematics, it's the exact same thing as induction, like word for word. So private something find and replace. I know that this has to be integer because when you're calling find and replace, it says that you also want to like return the number of elements of the replacement method. That's basically given to you. That is an integer. This is actually getting kind of tricky, so I'm not sure if I can. I want to have everything visible. I'm going to do annotations. Private integer, that's oversized, but that's fine. Private int find and replace. It's taking in something. Target replacement. This has to be the node, right? The node that you're currently working on. Oh my god, no, that's not gonna work. But I also need to see everything. Let me just grab the rest of this class, and then we'll zoom back in. Goodbye. Isn't it the last page? Let's check. The last page just has the question, but it doesn't actually have answers. Yeah. Unless it's not running for me for some reason. Yep, nope. It has the question, but it doesn't actually have an answer. Give me the whole code. You know what? Oh, okay. Someone did. Thank you. So it just wasn't rendering for me. Very cool. Chrome crashed. Very cool. Okay. Thank you very much. Yep, we got the int, we have the node current. If the current is null, the number is 0. Oh, interesting. I would have done it with current.next. But this works too. Current.null number is 0. Otherwise, the number is what you do from the current.next target replacement. Yeah, so current.next target replacement. Because your target and replacement are always going to be the same thing. You're always going to look for the same thing, regardless of which node you're on. Same with the replacement. If current.value is equal to target, then you perform the replacement, you number.++, and you return a number. Okay, so if you want to if you can imagine it, when you're calling this on a linked list, you're basically going all the way to the end of the list first, and then you're working your way back one by one by one. So execution goes, all of this stuff is initialized, and then number equals find and replace current.next. You move forwards one, and then you move forwards one again once current.next gets the same call. Current.next.next gets the same call until you get to the end of the linked list. And there you get your first return value, which is number.0. So now it gets returned, and now that we are like one off from the very final value, that number is now 0 because the final one returns 0, and we check if this value is of the replacement target, and if it is, then we add 1 to the number. And let's say for the sake that it's not. So that number stays 0, nothing has changed. This one resolves, it returns 0 to the next one after it. This one is now undergoing execution, so it checks if this one's value is equal to the target. If it is, we do the replacement and number ++. So now this one returns 1. If the next one is also being replaced, then that one just got passed in from the previous one. That one gets a +1, +1, 2, so now it's 2. And this happens all the way back to the start. If replacement does happen, you get and add 1 to it. Otherwise, you don't. That's really all you need to do. And by then, we've hit the very first one, and you just return the number. And that is how this method works. Does that make sense? No. Over here is just how you would call it. Yeah, so you start at the first one. You have your typical null check, of course, and you start at the head. So this one just has to start at the head. You could literally call find replace head target replacement, and it'd be the exact same thing. But this one just means that you don't have to specify head anymore, which is an instance of a method overload, by the way, because the parameters are different, but the name is the same. So did my explanation make sense? It's going to the very end of the line and working its way back. Each time that it finds something, it adds 1. Perfect. Thank you very much. Where'd it go? What is the int return, though? How many times we went through to find the target? The int returned is, it is how many times we find the target and we did the replacement. It counts the number of replacements. It starts at the very end. Each time it finds one, it adds 1, and then gives that number to the method call before it. And if that one, it adds 1 again, passes that along, and that number just gets passed along until we arrive at the total. Where did my thing go? No problem. What was it called? Are you it? You're it. That's question 2. Question 3, dynamic circular array list. Why does it specify dynamic? I've never heard of an array list that wasn't dynamic. Dynamic probably just means that the data structure can handle any number of things that you put in it. So an array is not dynamic. If you declare an array of size 3, that memory for 3 elements is going to be allocated, and you have that space to work with for your array. If you try to add a 4th, everything's filled, your compiler panics, and it burns. Array is a reference variable containing elements of a list. Yeah, it's a reference type. Size, because it's not primitive. Size is the logical size of the list. Class, the first one. What's the question? Oh, ensure space. Oh, that's what I meant by dynamic. It's actually stored as there's an actual array in here, so it's like a fake. It's like a fake array list. Oh no, it isn't array list. Oh no, it is an actual one. Yeah. This method makes sure the list will be able to complete the source code for the implementation below. More fill in the blanks. Ensure space. What I'd expect is each time you call add, I just got reminded that around 15 minutes I will have hit the 2-hour mark. So we should start wrapping up. In that case, we can probably save this one for later because I think we have covered something very similar to this in Lab 9. And if you have like a decent grasp of the OOP fundamentals, you can take a look at how Lab 9 works and how the playlist expands itself as sounds are added. That's more or less how ensure space works. Check the size. If it's smaller, you expand the array, you put everything, all array into the new array. It's not efficient, but that's how array lists work. All of that is more things to do with array lists. Let's get to the ones with the BSTs. Oh, hello. Oh, you are the BST questions. Are you? This one is. Lists and binary search trees. Oh, the prof will be doing this tomorrow? Wait, then I should have done a different exam. Whoops. Okay. But this one has to do with BST, so we can quickly go through them. Specifically, we'll be using the following interface list. That is very standard. I'm not going to read it. Build sorted list. If I recall correctly, there is something you can do in a Tell me the 2 questions you did before these 3 questions. Somebody want to find a different exam? Otherwise, I'm probably just going to end up repeating the professor, but I don't think this time. We'll just quickly go through what a build sorted list, I suppose. Unless there's other concepts you would like to cover. I'm pretty sure the professor is going to talk about what in-order traversal is. So a list would be a collection of nodes. In-order traversal just means that you read the value of the node that is less than the current node, then you read the value of the node itself, and then you read the node of the value after it, and then you go up one. Oh wait, no, you don't go up one. Yeah. And in doing so, you end up with the actual sorted list. Let's get some visuals. Let's see. Whoop. Why is Chrome crashing on me? Murphy's Law, I guess. .2012 exam is nice. Let me just quickly go over what in-order traversal is, just so that because I already started it. Can we get an example of the BST? Hello. Where did the chat go? Hey. Very cool. So yeah, in-order traversal, you start with the node after it, then you do the node itself, and you just do that for the entire list. So here, if we start on the root node, we know that we should add the node to the left of it first. So we go all the way down here to the 3. This gets added, then the 4 gets added, and then we go down 1 because we're adding this one next now that we've exhausted the node to the left of it, the node itself, and then 5 gets added next, then the 6, and then the 7. This entire branch is exhausted, so the 9, having done the node here and the node after it, and the node to the left of it, the node itself, it goes to the right, so on and so forth, until you finish the tree. But yeah, let's take a quick look at the 2012 exam then. I feel like I should have covered more about node-based data structures. It would have been nice to have an example to go through. I will keep that in mind for next time. 2012 exam. Statement time. Java, there are two ways of comparing objects by identity or by content. Which of the following two statements compares an object by identity? Identity, I'm assuming, refers to. Yep, this ends at 9. We'll end at 9. 2 hours by content. I do know that this compares the actual reference of the object. So if X and Y are both pointing to the same thing in memory, then this would return true. But dot equals is overridable by the two objects. So X can store a whole bunch of stuff, Y can store a whole bunch of stuff. And with their equals, they would check if both of them are the same instance of the class and they store the same things. So in other words, equals would check if it would compare objects by content, and the double equals would check for identity. Oh, thank you very much. I will admit, preparing for this session took a lot out of me, took a lot more time than I expected, but it's likely. I can see myself doing this in the future, in later years. But let's hurry up with this exam. So in Java, there are two paradigms allowing for the creation of data structures that can be used to store objects of various types, generics, and inheritance. Following two what? No, you can't use inheritance to polymorphism, I guess. Which of the following two paradigms allows the detection of type errors at compile time? Type errors at compile time? Generics, I would assume generics, because yeah, I don't see how it could be inheritance. Polymorphism maybe, because that has to do with casting, but generics by specifying, remember the triangle brackets when I showed with IVSOR and the unsafe operations or something? That is what generics helps prevent. Oh, thank you very much. Statement CMP is what? Produces a compile time error. What's CM? Oh, here you are. True or false? So public static mode vein, you have these two numbers equals those taken to booleans equals this is static, this is static. Static methods can call static other static methods. That is cool. A equals B, result is true, return result. It's returning a boolean. And okay, so it is storing it. So these are longs. This would cause a compile time error. This would cause a class exception. Dylan, exactly, yeah. And if you're going from an int to a long, that is perfectly fine because there's no data loss. Because longs, you can imagine them as ints, except they have like a ridiculous amount of decimals. So that stores more data. And oh yeah, that stores a lot more data. So when you're putting a long instead of data type of an int, the compiler takes a look at all that data and realizes, okay, well, do you just want me to discard that? And if you don't say that explicitly, it's going to throw a casting error because you just lost data that's unsafe. The compiler wants to warn you of that. You solve that by saying boolean CMP is equals to equals, and then cast the I into an int, cast the j into an int, and then you are perfectly fine. Please note that this type casting has nothing to do with the object type casting that I talked about earlier. I'm pretty sure you can Google the differences between casting primitives and casting objects in your own time. So yep, Dylan, you are right. Two more methods in the class may have the same name as long as their return types are different. They may have the same name, but not for this reason. A method's signature is its name and its parameters. I guess the return type. I'm going to say false, but my understanding of this one is nebulous. I would have to test the name, and because this is testing out what you know about overloading. So I showed you earlier that you had like two methods, attack, and then one of them didn't have parameters, and one of them did. Even though they had the same name, that was acceptable because the parameter is different. They have the same return type. I'm not entirely sure if you change the return type of the compiler would be able to tell. My guess would be false because that wasn't covered in overloading. I would have to, can we test it like right now, really quick? Like really, really quick? Really, really quick? Let's see, my suspicion is no. Yeah, okay. So you cannot. That's not how generics works. This isn't how generics works. It's false. You got that so. The following program displays yeah. So that is true. Cool. Everyone here knows what they're doing, it seems. Displays true. Counter. Both of you are right. Increment values plus, get value gets the value itself. Counter A, B is new counter B. What is this? Oh, increase. Increase value. It's instantiating itself. I really hate it when people put the main method inside of the same classes they're working with. It's just really messy, and the professors unfortunately seem to really like this. I love projects that have like a dedicated runner class, so you can actually see what's going on. You know what to run when you're doing the console. This works. It's just messy as hell. Get value. B dot get value, yes, equals 1. B equals new counter. I think value would be 2, because I showed you the exact same thing earlier with attack count. Remember, we created 4 different instances of Pikachu, and they all increased the attack count, and you ended up with 4. Here, you're doing the same thing. You have A and B, you're creating 2 instances of that, both of them getting incremented. So now increment is at 2, not 1. We need to do B dot get value. Wait, no, this would fail for another reason. Get value, return value. Oh, no, that's fine, because even though this is non-static, it can still access static things, but this will return false just because it's 10 into 2. Yep, it's a class variable. Constructor cannot have a value return type. Yeah, true. Reference variable type T, otherwise it's not a constructor. T as an interface can reference an object class S is or one of its superclasses. Where T, if S or one of its, yeah. This is the same thing as upcasting. Remember how I stored trainers and Pokemons inside an array inside the data type of interactable? That's more or less what this question is asking. It's just worded really difficultly. So that is true. Same thing as Pokemon and trainers being stored in interactable. Name this refers to a reference that is always available to an instance of methods and refers to the object itself. True. That can work. I think it's what you... Yeah, you got it. That is polymorphism, and it is called upcasting. A method that has exception of class, runtime exception of... No, I appreciate it. Thank you so much. Runtime exception or one of its subclasses must declare this exception using clause. Runtime exception. Oh, here we go. Runtime exceptions versus compile time exceptions. My own understanding of this is fairly nebulous. Did I talk about it in here? Might have. I need to check my own notes, honestly. But I did give an example of this. I know that a legal argument exception you don't need to throw because it's not. What are the 2 kinds of exceptions? I know that there are 2 different kinds of exceptions. One of them is like assume that, okay, if it happens, then the user can get over it. This is what we saw in assignment 1 like we saw this throws exceptions. This is because this is because we're doing some file somewhere down the line, and it's probably in this method. File IO somewhere down the line. Hello, yeah, new file. So we take a look at the files constructor. And see what kind of exception it throws. Hello, here you are. Throws null pointer exception only. It's something else then. Might have been a scanner, but it's probably a file not found exception. Yeah, and this is the kind of exception that you would need to throw. False. Hang on. First, each is false because there are some cases in which I think it specifies instance method. This means that for the methods they'll operate on, there'll always be methods that aren't static. And for those methods, you always have access to the instance that it happens to be in. So that's why this will always be a keyword available to you in these methods. I'll be very surprised if this was false. Yeah, so this dot method would, yeah, it's not asking whether you can call it this dot method. It's asking if it's available in the scope of the instance method. But either way, I am out of time. So thank you all for attending, and I wish you best luck for the exam. No problem, and my pleasure. I hope it helped. My pleasure. Good night, everyone, and don't hesitate to ask if you have any questions remaining. Oh yeah, I have to stop the recording.